Alright, we have discussed about how to find the area bounded by a line and a curve. The line could be a horizontal line or could be an oblique line. So now we are discussing on how to find the area bounded by two curves. Take note that this is an extra example and you might want to copy down somewhere in your lecture notes. Now for this example, we are required to find the exact area bounded by two curves, y equals to x minus 1 whole thing square and y equals to negative x squared plus x. So of course in our mind we can't visualize how the graph may look like, so we need the help of our GC. So key in the first graph and the second graph, and let's see how the graph look like. Okay, based on the graph, you can't exactly see where is the region that we're going to find. So what we're going to do is we zoom in. Number 2. And select the region where you want the calculator to help you zoom in and press enter. Based on the image that you can see here, it's actually not so obvious which region we are talking about. So what we're going to do is to zoom in one more time. Press zoom in again and go to the region where you want the calculator to help you zoom in. This is better. So essentially this is the area that the question wants us to find. We are interested in the lower limit and the upper limit when we integrate. So the lower limit is actually the x coordinate of this point of intersection, and the upper limit is the x coordinate of this point. So how am I going to do? I'm going to calculate the intersection point. Right, so go close to the first intersection point that you want to find and press enter. As for the second curve, similarly go close to the point that you want to find and press enter again, and one more time enter. So the x coordinate is clearly 0.5, which is half, and we do the same for this point. Second, trace number 5. Right, go close to it, enter. Second curve, enter, and make a guess. Right, the x coordinate here is 1. So we know we need to integrate from x equals to half to x equals to 1. To find this shaded area, since I know this is x equals to half, this is 1. What I'm going to do is I integrate from half to 1 of the top graph minus the bottom graph. Take note that this top graph here is actually y equals to negative x squared plus x, and the lower graph is actually y equals to x minus 1 squared. So integrate the top graph minus the bottom graph. Which you eventually arrive at integrate from half to 1 of negative 2x squared plus 3x minus 1. So you will proceed on the remaining steps and eventually you should be able to get 1 over 24.